Hello and welcome. Today, I want to be walking you through just a very basic data analysis problem. What I want to do is I want to take a lot of the things that we've been discussing over the last couple of weeks, and I want to break them down, or actually kind of build them up actually, into one example that unifies everything, that kind of shows how it all relates together. Now today, what we're going to be using, once again, as always, we're going to be using SPSS 23. Everything should be backwards compatible and hopefully future compatible, as well as using the federal sentencing data set from 2006. We're going to be using a subsample of that data set, about 2,000 individuals out of that data set, and this will make the numbers a little bit more realistic for typical data sets. Most data sets aren't going to be using about 72,000 plus individuals in there, so it'll make it a little bit more realistic, more likely what you are going to encounter in your various projects that you do. So the first thing we want to talk about are what variables we're going to be using. Now I've eliminated all the other variables out of here. We're going to be primarily looking at 6 major variables, 2 different kind of primary hypotheses. And what I wanted to do is have a dependent variable that is measuring the same thing, tapping into the same concept, but it's being measured in 2 different ways. So we have 2 things. One, we have sentence length, which we've been playing with before. This is the length in number of months that the defendant received from the judge for their individual during sentencing. We also have what I call an in-out decision. This is used oftentimes in the sentencing literature. This examines whether the person was sentenced to prison or not. So essentially it takes all those sentences where they got 0 months in prison, some type of withheld sentence or probation only, something like that, and it puts them into the category of 0, being no prison. And then everyone else who got at least 1 month or more, so they either went to jail or prison, got a 1. So this it measures the same thing. Both of these measure the severity. The sentence length is a continuous variable, a metric level variable, whereas the in-out decision is a dichotomous variable, nominal for all intents and purposes. There are a few other variables we want to kind of examine. Today, my big thing is I want to look at gender. I want to see how does gender play a role in either the length of someone's sentence or whether they go to prison or to not released into the community. This is going to be measured as males being 0 and females being 1, so it's a dichotomous variable once again. We also have race in here as well. This is going to be one of my control variables. The literature is very clear that race does play a role in sentencing. It's a complex relationship. But just for ease today, what I've done is I've created a dichotomous variable where 0 is white defendant and 1's a non-white defendant. Generally, the literature indicates that individuals who are non-white individuals are more likely to experience harsher sentences or more likely to go to prison as a general rule. But once again, it's a complex relationship there. We also have offense severity and criminal history points. These are both come from sentencing worksheets where the judge is trying to assess 2 characteristics. One is how severe this crime was, and that's the offense severity points. So this is a score that starts at 0, meaning the lowest value possible, and escalates up from there. So higher values mean a more severe or more serious crime. Same thing for criminal history. 0 means no criminal history at all, or no criminal history points were applied to the sentencing. And then it increases in value up from there. We'll take a look at the frequencies here in a second to get exactly an idea of what that looks like. But the main relationship we're looking at today is sentence length and the in-out decision versus gender. And most of the literature tends to indicate that as a general rule, all variables controlled, men, if there is a difference, tend to receive harsher sentences, so longer lengths of sentences, or more likely to go to prison when compared to women. So we want to examine in this subsample of 2,000 individuals, is this correct? Does this relationship hold up in our data? And then we also want to control for some of the other factors to see if maybe once we control for things such as race, offense severity, and criminal history, does that relationship go away? The first thing we got to do, though, is we got to examine the descriptive statistics. So in order to do that, we want to look at what our data looks like. We're going to go down to descriptive statistics, and I'm going to use frequencies here just to make sure we got all the information we have and everything like that. Now, the first thing I'm going to do is I'm going to look at the dichotomous variable. So I'm going to grab in-out, defendant's gender, and race. I'm going to pull those over, and let's get what statistics we would want from those. Now, a mean might not be really helpful here. I'm going to grab it since they are dichotomous because it actually gives us the percentage. It's an average of 0s and 1s. So that the mean will tell us actually the percentage of 1 values within the data set. But the mode is likely to be the most important thing we would want. Which category occurs most often? We're going to be able to detect the min-max value, obviously, because it's bound by 0 and 1. Standard deviation doesn't help us a whole lot, but we can request it if you want. We know what the range is, but we can look at the percentage of the distribution. So let's get this. For charts, I'm going to go down and I'm going to request a bar chart so I can kind of see how that's plotted out, and let's request it. take a look at the information. So this is the overall information, right? So the mean and the mode. So what's the most common value? 1 is most likely to be sentenced to prison, 0 being men are most prevalent in the sample, and 1 being non-white defendants. 73% of the data set is non-white, 12% of the data set is female, and 81% has been sentenced to prison. So we can come down here and take a look at this, and lo and behold, yep, we can see exactly what we're looking at. So no prison, about 18%, prison jail, 80%. We got about 16 cases missing on this variable alone. When it comes to defendant's gender, yep, we have about 86% are male, 11% female, with about 39 cases missing a gender value. And then when it comes to race, 103 are missing race variable here. That's 5%. Okay, that's an amount. 25% are white, about 70% overall are non-white, with 5% of that missing. So once again, the valid percent gives you the percentages without the missing values. So when we get some graphs here, we can see this bar chart kind of visualizes the kind of the disparity between the two. Defendant's gender, once again, there's a lot of male cases versus female cases. Might not be ideal. If we were doing more advanced statistics, we might have to do something to correct for how disproportionate this is, but let's focus on the basics here. And then white defendants versus non-white defendants. Okay, so now that we got a good feel for that, we know what our data says. Now let's look at the rest of the data. The other 3 variables that we didn't look at. So let's go over to frequencies. I'm just going to reset this because we're going to get the other variables now. Sentence length, offense history. Don't want to do that. And criminal history points. I'm going to pull those over. Now, since these are metric level variable, either independent or ratio or interval level variables, and that's what I mean by metric, right? They're interval or ratio level in their measurement. I can grab the mean is probably going to be a much more important statistic, but we can grab the median and the mode as well. The median is really going to be the big important one. So I'm going to take away the mode. You can run it if you want, but we'll grab the median. Standard deviation is going to be important here. Min-max values are important. We can grab the variance if we want, but it's related to the standard deviation. We should be good there. For charts, I'm actually going to grab a histogram. And what this is going to do is it's going to show me the distribution of the values. Bar charts are great for dichotomous variables or ordinal level variables. Nominal level and ordinal level measurement is fantastic. But for metric level, let's grab a histogram. I'm going to click continue and click OK. And we'll go ahead and see what we have here. So when we talk about the number of months someone's sentenced to, it seems like the statistical average is about 52.5 months. So that's the average sentence that was handed down. The median, though, okay, the value that splits this data set in half is about 28. So that's kind of important to understand there. We got a final offense level as well. So this ranges, because it's important, the minimum offense level was a 2, the maximum was a 43. That's important to be thinking about, with the average being about 18.7. And the median, so the value that splits that into high and low, the upper or lower 50%, is 19. When we examine, get that out of the way there, the criminal history points, we see that the average is about 3.5. The median being 2, so a little bit below that. But the maximum being 46 points, with some people having 0. So this really tells us we have a very strong skew within this variable. Once again, if you're doing more advanced statistics, you might need to correct for this. So we have a frequency table of all the values of the sentence length handed down. Now this is, since it's such a large table, you may want to select and delete this. It kind of depends on what you're doing with your output. Same thing for offense level, it's not quite as long, but we can see where these kind of points are that a lot of these values pop up when we start hitting kind of triple digits. This gives us kind of a numeric understanding of some of these values. And the same thing for criminal history points. No, it says no criminal history points here because we defined 0 as none applied. So that means there's nothing, there was 0 there. 33% of our sample, a lot of people with no criminal history. So we could almost create a dichotomous variable here if we wanted to study how do people with no criminal history versus some criminal history differ, but for another analysis. And then we have some histograms here, and we can see once again we are really skewed here. Most sentences are on the low end, but we have some really high ones out here that are making this graph very ugly, essentially, to look at. This is one of those things that if we are really going to a very serious data analysis, we might actually want to think about truncating this. In short, once we exceed 1,000 months, are we really, for all intents and purposes, how much more is that than 3,000 months? Like quantitatively, it's 3 times, but like those people are very similar in the way to 3,000 months is that they're very severe penalties that were handed down. So it might create kind of that pulling of the variable way out there is basically diagnosing what we call outliers. But once again, let's run with the data how it is here, but do be aware that this would need to be cleaned to some degree because these really extreme values are going to pull our statistics way out there. Offense level as well, we can almost see kind of a little bit of a normal curve breaking out here with this value right here. Looks like 21, 22, something like that. A little bit. It looks a little bit better than what we anticipate. And once again here, the most individuals receiving nothing, but there are some pretty extreme values above 40, lower than 50. So this gives us a visualization of a visual look at what our data looks like. So what we can do is let's proceed forward. So we've talked about what our variables look like, how they're defined. Let's start walking through some very basic analysis. And what my primary investigation question or hypothesis today is, how does gender impact sentence length and the in-out decision? So if we wanted to do crosstabs, okay, and run a crosstab to examine what the relationship is. Now, here's the thing. You wouldn't be able to run a crosstab or a chi-square analysis on sentence length. However, what we could do is we could cut it into high and low values. So, for example, we could take sentence length. If we really wanted to do a crosstab on that, we could actually recode this into a new variable. So we could get sentence length, okay? And we can, I'm just going to reset this and do it from scratch. So we can pull sentence length over, and I am going to create a high-low sentence is what I'm going to call it. And basically what I'm doing is I'm going to split this based on the 50% value. So once again, if we go over to our output and we scroll up here to the sentences and we look at the cumulative, I want to see where this splits between over and under 50%. And I find it's at 72 months. So 72 and under is under this half mark, and 80 or 28 and over is over the half month. And we can see that too by looking at the median. This is the dividing value at 28. So we should feel pretty comfortable in that. So what I'm going to do is I'm going to define old and new values, and I'm going to define these as from 0 to 27. I'm going to call this as 0, and we're going to call that the low category when we code it here. And then it was 28 through the highest value. I'm just going to put 9999. We also could have said through highest value, coded it here. Code this as, pardon me, a 1. So basically all we're doing is we're making a new variable to analyze sentence length as a categorical variable. And I'm just splitting it on the top and the high and the low 50%. You could split it on the mean, which one is again about 52 months. You could do it that way as well. So tons of decisions. You should be theoretically driven. Once again, I'm just kind of doing this to walk through the steps and show you some of the different things you could do and kind of how to put all of these items together. So we're going to click OK. It's going to create that for us. I'm just going to delete that log entry. Make it nice and clean. So we have this new variable. So now let's examine what a crosstab analysis would look like. Gender predicting or explaining sentence length, and gender explaining the in-out decision. Let's start with sentence length, and once again, since we need a categorical variable for a chi-square analysis, to use the high-low. So we are going to go to descriptives and go down to crosstabs. And what we want to do, remember, is pull one of these that we're interested in looking at. Remember, you would never use sentence length because this is looking at categories. This is for nominal and ordinal level variables when you're conducting a crosstab analysis. If we run it like this, we're going to get a really nasty thing. So we're going to have one column or row for each sentence that was handed down. It's really going to look ugly. It's not going to be interpretable. So let's use the high-low and pull that over. And I want to examine defendant's gender. And let's run this. Let's ask for chi-square, okay? And what I want to do here is, let's see, column, row. Let's get this. I always get this stuff mixed up. You're seeing me doing this live for the first time. Let's go ahead and get row percentages. So I want the percentage based on the row, and I don't think that's right, actually, but let's run it and see if it is. We can just delete it out. So, yep. Okay. So what we can see here is that this is splitting between men and women, and whether they had a low sentence, so below that 50% threshold and above the 50 percentile threshold. So we have about 3% being kicked out, not bad, 97% good. And we look down here and we see, yes, chi-square is statistically significant. So what this tells us is, and when we look at this, right, of people who received a high sentence, or in this case, a low sentence. Remember, 0 is low, and this is bad of me. I made a mistake here. I am going to delete this and correct my mistake. I need to define what these categories are so we can keep track. Remember, 0 was the low individuals, 0 to 27 months, and 1 was a high sentence, and that was 28 to the top amount. And once again, this was my mistake not doing this after I created that new variable, because now when we run this analysis, okay, and actually I'm going to swap these. All I'm doing is just swapping them on there, and then we're still going to run the same row here, but I just wanted to swap them to make this a little bit more interpretable, and I'm going to click OK. Aha, here we go. Same type of data. All I did is I flipped these around. That's all I did. Okay, so once again, we're still statistically significant. So this tells us we have a Pearson square of 50, 1 degree of freedom, so the statistical significance is 0.000, so it's something really, really small. Keep in mind, this is non-zero, but it's really low. So what this tells me is that there is a statistically significant relationship between these two. There is a relationship. We have enough cases and a strong enough relationship that we can say, yes, this is statistically significant. When we come up here, we can examine out of men, okay? So this is 100% on men, so all men. 46% got a low sentence and 53% got a high sentence. Okay. When we compare this to women, and this is why I wanted the percentage on gender, which was male and female, and that's why I swapped these two, because they were column before. With females, 71% of the women in the sample got a low sentence, and 29% got a high sentence. So by looking at this, right, when we compare, out of the high sentences, 53% of men got one, and 29% of women. So what this tells us is that realistically, women were more likely at 71% to get a low sentence, and men were more likely to get a high sentence at a 53% of all men. So there's a significant difference here, about 30, 40, 50, 20% difference between the two groups in who's more or less likely. So this is really important to interpret the relationship. So here we would be able to make the argument that, yes, we have a statistically significant relationship in that men are more likely to receive a high sentence, where women are more likely to receive a low sentence. Okay. We could also run this for the in-out decision, and my assumption is it's going to be very similar. So instead of having the high-low decision in here, we could pull out the in-out decision. Remember, this is whether they went to jail or prison, or they were just released without any time duration. So when we run this, we're probably going to get a similar story. It looks like it. Right? So we have here, and this is the previous analysis was up here. This is a new one, right? Examining the in-out decision. So we find men, 14% did not get prison, where 37% of women didn't get prison. When it comes to getting prison, 85% of men got prison, only 62% of women. So there, once again, is a difference where it seems like judges are sentencing women to not as... they're less likely to receive a sentence in prison. And once again, chi-square is at a value of 75. The statistical significance, once again, is below 0.05. So we can say, yes, this finding up here is statistically significant. We have enough cases to make this claim, and the relationship, the difference between these is strong enough to support that based on how many cases we have. So we should feel pretty good here. We've been able to examine crosstab examination of these variables to see how this kind of breaks out. Now, let's do another step. Let's do a regression here. Because the question becomes, well, we want to be able to control for gender, or we want to control for race, offense severity, and criminal history. Because it could be, in this situation, that men may just commit more severe crimes and have longer sentence or longer prior histories. And that's why, in just an analysis of race, gender and outcomes, that's why men are getting longer sentences. But if we control for the fact that maybe men commit more serious offenses, maybe that will explain it rather than gender. Okay, and this is the difference between legal and extra-legal variables within the sentencing literature if we're kind of going to the theory. So let's examine this using a regression equation. First off, let's examine an OLS, or a linear regression, where we're going to basically predict the sentence length variable. So we're going to go up here to analyze. We're going to go all the way down to regression. And remember, we're going to use linear regression. The reason is because the dependent variable, in this case, we're going to use sentence length first. This is the number of months. Number of months is a ratio interval level variable, a metric level variable. So we want to use linear regression. And we can pull this up there. So we can grab, where is it? Sentence length right in front of me. Pull it up there. And then we can bring gender in. Now let's just run this alone real quick. Let's just see if sentence length is different based on gender, and it should be. We've already run this, although we did the high-low. Let's see what this looks like, and lo and behold, when we run it, we find we're not explaining very much of the, we're explaining less than a percentage of all sentences by using gender, but that's okay. So here, when we examine, it's statistically significant in the analysis of variance, so that means we can continue on, that there's something in here to look at, and lo and behold, we have defendant's gender, and remember, what we're doing is we're predicting the number of months, in this case solely based on gender. So this is the number of months when we go from the 0 to 1 value. Now once again, let's review what was the 0 to 1 value. When we go from 0 to 1, we are going from male to female. So as we go from male to female, okay, that means there's a reduction of 32 months in their sentences. So women receive sentences because women are 1 and men are 0. So we're going from 0 to 1. As we 1 point increase in this scale, gender, we have a reduction in 32 months. Okay, this is a statistically significant relationship right here, 0.000. So we're below that 0.05 threshold. So we can say within this sample, we feel confident in saying, because of the effect size and the sample size we have, that women receive sentences less than men of about 32 months left on average. But once again, we go back to the question saying, aren't we supposed to put some of those other variables in there and control for other factors? Because this could be driven, once again, by men having more severe sentences, okay, or longer sentence lengths. So, or criminal histories, pardon me. So once again, let's go back into our regression. Can't hit it there. Go back to linear. And instead of just putting in gender, let's put in some of our other variables. So let's put in race, offense severity, and criminal history score. And what this should do is now it's going to control those. And let's run this. So now we see all those variables are in, still all predicting number of months. And we see now, lo and behold, look at this. The R square value, and we want to use adjusted R now because we have more than one variable in here. 0.297. Remember, this is 1 is explaining everything. So we're explaining almost 30%, 29.7% of all of the change in sentence length. So we've had a huge jump here. We're still significant here on our analysis of variance, so we can continue on, meaning there's something down here interesting to look at. And let's see what we got. So here we have defendant's gender. Now look at the huge decline. Before it was 32 months, now it's only 1 month. Women are a month and a half less in their sentences compared to men. And when we slide over here, look at this, we went over the 0.05 threshold. This means that we are no longer statistically significant on this value, meaning defendant's gender does not have a statistically significant impact on the sentences in this data, or in this sample. So even though this says, yes, technically women get 1.5 months less than men, because this is not significant, that means that there's not a large enough difference between men and women in this category based on how many people we have in our sample that we can really say this difference exists in the general population. So in this scenario, we would say, you know what? We are not able to say that gender influences an impact on sentence length when, and here's the key, we control for all of these other variables. And we might ask why. Well, when we go and look at the other variables, we see race in here. So remember, 0 was white, 1 was non-white. So non-white individuals receive sentences of about 7.2 months longer. But once again, that's not statistically significant. It's not below 0.05. So we can't make this generalization either. What does win the day is the final offense level and the criminal history points. Now remember, everything up here, the race and gender, were dichotomous, 0, 1. So we only have that one category, that one jump from male to female and from white to non-white. Down here, though, remember, a final offense level and severity, or history, pardon me, have a lot of different values to it, right? So for each one of, go back up to when we ran these descriptives, right? For each one of these points, so moving from 2 to 3, 3 to 4, 4 to 5, 5 to 6 on the offense level, or when it comes to history, right, 2 to 3, 3 to 4, 4 to 5, for each one of a 1 point increase in this, that means you get 6 months on the final offense level score and 3.1 months when it comes to the criminal history score. So for each additional point in the criminal history scale, you get 3 months added to your sentence, on average statistically. So someone who has an additional 3 points would get 9.3 months, right? So you see how this adds up depending on how many months. And this is because both final offense level and criminal history are metric level variables, interval or ratio level variables. So for each one change, one increase, you get this value, 6.1 for the offense level and 3.1. You see how now we could actually kind of predict. So if you walked up to me and told me that you had a male defendant who was white, who had an offense level of 4 and a criminal history score of 12, we could actually calculate what we would expect them to get, right? If they were, we could actually take the number of criminal history points times 6 and the number of, or criminal history points times 3, pardon, and the offense level score times 6. And then in that case, if they were white, this wouldn't apply. And if they were, male, this wouldn't apply. If they were Caucasian, this wouldn't apply. So in that case, we could actually do a calculation of how long those sentences would be. Once again, both of these are statistically significant, meaning we can generalize this back to the population. We can say that, yes, this is something that likely happens in the entire data set because the effect is so strong compared to how many cases we have. Now, notice that the raw effect size between these two is in this case, race is larger. But keep in mind, there's only one step going from white to non-white. In this, we have, 40 or 60 different steps we can go. So this has a huge impact. Once again, this is kind of an aside, but if you want to actually compare the strength of each one of these variables, you can go over here to the standardized beta, and it'll tell you the smaller the number, just ignore negatives because that's associated with the direction. The smaller the number, the bigger impact or the smaller impact it has. So once again, this is really driving a relationship at the largest value, 0.5, followed by criminal history points. And then these two are just minuscule by comparison. So what this analysis has told us, right, is that we have a relationship between offense level and criminal history. And what that does is it renders any effects of gender or race in this particular model statistically insignificant, meaning that the sentences are really explained by the offense level and the criminal history points, not by a defendant's gender and not by their race. Okay. Now let's run one more analysis here because I want to do a logistic regression model in the situation that you have a dichotomous dependent variable but still want to run a regression. You would want to run a binary logistic regression. So let's grab the in-out decision so that they go to prison or not. Let's pull that over into dependent. And then let's pull over again defendant's gender. Let's just look at that alone since it's our major hypothesis that we're examining and run it. So we start the analysis out. 3% once again excluded. Great. We can hop down here, Cox and Snell and the Nagelkirky. So we're not explaining a whole bunch of variation, but some, about 3% and about 5%, depending on which measure you use. And we look down here and go, lo and behold, look, gender is statistically significant with this exponent, once again, is telling us what are the odds, okay, of receiving it. So since it's lower, that means it decreases the odds of going into category 1. So it decreases the odds of going to prison. And in order to, I always have to cheat. So I'm going to on a calculator here, I have 0.283, and I'm going to hit the negative exponent thing, and it's going to give me a 3.53. So in short, this is telling me that men have a 2.5 times more likely to go to prison than women. Okay, and all I did is I take this 2.83 and I just went did it to the exponent -1, I got 3.5. But keep in mind, you always start off at 1. If this said 1, then that would be no higher, no lower. It's 1-to-1 odds. But this is 3.5, so it's basically 1 to 3.5 odds. So that's 2.5 times more likely to be going to prison. And remember, so this is a big impact. Now let's see if the relationship still holds if we are adding in the other variables. So let's pull in everything else, right? Race, sentence severity, and criminal history. Pull it on in, and let's run that model. And we can go down. Nagelkirky and Cox-Snell. Now look, once again, just like last time, these pop up. Now we're explaining huge amounts of the variation, almost 47%, 48% with the Nagelkirky. So this is indicating that we added a variable in here that's explaining a lot. And since we ran it beforehand, we should know that it's likely to be offense severity and criminal history. And lo and behold, that's exactly what we find, right? So here we find offense severity and criminal history explains quite a bit. For each jump, so each 1 point increase, we have a 25% increase in likelihood to go to prison, and criminal history for each point increase is a 34% increase in the odds of going to prison. For race, okay, we have a 63%. Remember, you get rid of one value on that when you're interpreting it. A 63% increase in the odds if you are non-white. And for gender, again, I have to cheat by hitting 0.403 in my calculator and the -1 exponent, which gives me 2.48. So that's 1.5 times more likely for men to be going to prison than women. And here's the thing. All of these variables are below the 0.05 value. So what this means is compared to the sentence length, when we're talking solely about in-out decisions, we're only looking at prison and only looking at non-prison. All of these variables make a difference. In this case, being male does tend to have a difference on whether you go to prison or whether you're released out into the community on probation. It seems here that Caucasians are more likely to be released into the community than non-Caucasians, non-whites. And it seems that offense severity and criminal history points, the more you have, the more likely you are to go to prison. So this also helps to explain and kind of demonstrate a larger methods issue that depending on how you measure the dependent variable, because someone could argue, well, both of these are measures of severity. One's just the number of months someone's sentenced, and one is just whether they were sentenced to prison or released into the community with 0 months in prison. So someone could really say, well, why don't these line up? They're both a measure of severity. The key here really comes down to level of measurement, what we're examining. Because keep in mind, going to prison or not going to prison is not the same thing as this sentence length. There's more variation. Someone who got 1 month in prison compared to someone who got 5,000 months in prison, both of those are going to be an in-prison individual within this data set. So, or within the in-out decision. Essentially, in this case, the in-out decision doesn't account for individuals who are vastly different, but still just both got sent to prison. So this is really important to think about how you measure your dependent variable, and perhaps not for any projects that you're doing to just demonstrate you can do data analysis. But when you approach projects that are really important, you really want to ask, what is important in measuring this? Do I need to measure this in months in prison? Is that really the story I want to tell? Or am I simply worried about whether the person does or doesn't go to prison? So that's all theory driven. It's all driven by what you want to know and what you want to examine. All right, so we've done a variety of things here. We've talked about how to run frequencies. We've talked about the hypothesis in this example we've run. We examined all the frequencies, how to bring up some charts, tables, graphs, things like that. We did a crosstabs analysis so we could kind of examine how that works with chi-square. And then we did an OLS regression, a linear regression, as well as a logistic regression, and kind of talked about how to interpret those. I really hope this has kind of brought all the other pieces that we've talked about in the past together, so you can kind of get a feel as to how all of them go together. We even did a quick recoding there on the high and low when we ran the crosstabs. Just remember, label your categories. Don't do what I did. If you have any questions, please don't hesitate to contact me. And keep in mind, this is a very crude example. It's a very quick example. Don't extrapolate any of this onto sentencing theory because I have constrained the values to kind of demonstrate some things within this example. Once again, good luck on your data analysis. Any questions, don't hesitate to contact me. Have fun.